The cosmic landscape of our universe is changing in mysterious ways. More than 771 trillion nearby planetary groups have inexplicably vanished, leaving the scientific community in confusion. This disappearance has raised numerous questions. What caused these planetary groups to disappear? Could there be a connection between their vanishing and the emergence of strange cosmic phenomena? Join us as we explore the vast, unfolding mysteries of these missing stars. Over 771 trillion nearby planetary groups have vanished without a trace, leaving behind a perplexing void. As we delve into the reasons behind this phenomenon, we also look at new, unexplained components emerging from the depths of space. The idea that matter doesn't just vanish but transforms, much like the remnants of a star after an explosion, challenges our understanding of the universe. The disappearance of stars is not entirely unexpected, given the vastness of the cosmos. Stars can vanish for a variety of reasons. They may reach the end of their life cycle, collapse into a black hole, or undergo some other cosmic event. However, what makes this situation unusual is the sheer scale of the phenomenon. It's not just a few stars, but over 700 trillion that have seemingly vanished, many without the usual signs of a cataclysmic event. This presents a significant scientific mystery. Fortunately, a team of dedicated researchers, particularly from the Nordic Foundation for Theoretical Physics in Sweden, is working to unravel these cosmic secrets. Their project, known as VASCO, aims to identify a type of star that has been a consistent presence in the night sky, only to disappear without any prior warning or evidence of what happened to it. Despite the challenges posed by the enormous distances in space, this project has been active since 2017 and has gathered significant attention. The goal is to find a star that suddenly shifts from stable to completely vanishing, a phenomenon not yet observed in astronomy. Most stars, like variable stars, undergo changes over time, but the disappearance of a star without any observable remnants would be a groundbreaking discovery in the field of physics. One such example that has captured the interest of astronomers is a star that had been closely observed for over 20 years. This star, known for its brilliant blue glow, suddenly disappeared in 2019. The initial hypothesis was that it might have exploded, turning into a black hole, but no signs of a typical cosmic explosion or black hole formation were found. This led astronomers to consider the possibility that the star may have transitioned into a black hole without any observable explosion, a scenario that challenges our understanding of how such processes unfold. The idea of stars disappearing without notice isn't entirely new. In 2009, another star appeared to be heading toward a peak before mysteriously turning into a black hole. While concrete evidence for these events remains elusive, they have left scientists with many unanswered questions. The study of transient objects, which appear suddenly in one observation and vanish in the next, has provided valuable insights, but it has also complicated the task of categorizing these events. One promising theory is that the vanishing of stars may be related to how light travels across the vast distances of space. Light from distant stars takes billions of years to reach us, and by the time we see it, it is often mixed with the light from other stars like our Sun, which is much closer. This raises the fundamental question of how we can observe distant stars at all, and how the light from these stars behaves as it travels across the cosmos. In conclusion, the disappearance of 771 trillion planetary groups presents a profound mystery for astronomers and physicists alike. While there are many possible explanations, this enigma invites us to reconsider our understanding of the universe and the phenomena that shape it. The age of light from stars far away can often be surprising, as the light we observe may be much older than we realize. The seemingly quick disappearance of stars might be a result of the vast age of the light we are seeing. Even though the star may appear to vanish suddenly, it could have ceased to exist long ago, and we are just now witnessing its absence. This idea also aligns with the notion of stars going through long periods of brightness followed by gradual fading until they eventually become undetectable. While this is a perplexing concept, it raises important questions that should be explored to uncover the truths behind these peculiarities. Some people have become fascinated by theories like Dyson spheres and other grand possibilities, often considering extraterrestrial beings and their potential role in the fate of stars. You might wonder how extraterrestrial life could be connected to disappearing stars. Rather than causing stars to vanish, these beings might harness the energy of stars for their own purposes. A Dyson sphere, often a concept found in science fiction, imagines an advanced civilization constructing a massive structure around a star to capture its energy on a large scale. This energy could be used for various purposes, possibly even to power immense technology. While this idea is similar to the star-destroying energy in Star Wars, The Force Awakens, there are significant challenges to making such a concept a reality. First, the existence of extraterrestrial life remains unproven. Second, constructing a Dyson sphere would require immense time and technological expertise, far beyond what we can currently achieve. Additionally, applying this idea to over 700 trillion stars seems like an impossible, infinite endeavor with uncertain odds. Nevertheless, this idea still fascinates many, despite the many obstacles. The key question remains: what is causing so many stars to seemingly disappear in such a short period of time? This phenomenon cannot be dismissed as an isolated event, as we have observed the noticeable absence of multiple stars. Scientists and researchers are deeply invested in unraveling this mystery, as finding answers could provide us with a deeper understanding of the universe. If similar events occur in the future, we may be better equipped to quickly analyze their causes. At the same time, something remarkable has emerged from the depths of space. Astronomers have discovered vast cosmic voids that exceed our initial expectations. These voids, like the Boötes void, represent areas where matter is conspicuously absent. The Boötes void, also known as the Great Nothing, spans about 330 million light-years and is located near the Boötes constellation, around 700 million light-years from Earth. Originally thought to contain only one galaxy, recent discoveries show that it holds a few dozen galaxies. However, the distance between these galaxies is vast, around 10 million light-years, which is many times greater than the distance from Earth to the Andromeda Galaxy. To put the scale of the Boötes void into perspective, consider the nearby Virgo supercluster, which is only about 110 million light-years across but contains over 2,000 galaxies, including our own Milky Way. In contrast, the Boötes void, if it contained the same number of galaxies as the Virgo supercluster, should theoretically have around 10,000 galaxies. Instead, it contains only about 60 galaxies, making it one of the loneliest regions of space. One of these galaxies, MCG plus 0102-05, was captured by the Hubble Space Telescope and is considered one of the loneliest galaxies in the void. The reason for its isolation remains unclear. How do such voids form? Smaller, more common voids are created by the gravitational attraction of galaxies pulling matter together and leaving empty spaces behind. However, this explanation doesn't apply to the Boötes void, as there hasn't been enough time since the Big Bang for gravitational forces alone to create such a vast gap. This leads to another theory about the universe's formation. While many envision the universe expanding uniformly after the Big Bang, a more complex pattern emerges when we look at the universe on a larger scale. Shortly after the Big Bang, the universe was an extremely dense and hot plasma. Despite being mostly uniform, tiny fluctuations in density existed. As the universe expanded, these small variations in density became more pronounced, leading to the formation of large-scale structures like galaxies and voids. Fast forward 13.8 billion years, and we can now see how these early quantum fluctuations evolved into the large structures we observe today. These variations in matter density have shaped the universe into the cosmic web we study, with galaxies, galaxy clusters, and vast empty spaces. The true causes behind these cosmic phenomena remain a subject of ongoing investigation, but understanding them could help us better comprehend the vast and mysterious universe we inhabit.